Who would win in a fight? Dozens of Clippies or one ChatGPT? Well, researchers recently released a paper which suggests that you can use multiple open source off-the-shelf models to outperform the state-of-the-art model. And not only that, doing it cheaper as well. So how do they do this? You'll find out right now. Today's paper is Mixture of Agents Enhances Large Language Model Capabilities and comes from the company Together AI, with affiliations with Duke University, the University of Chicago, and Stanford University. Welcome to the channel. If you're new here, my name is Hong and I am fascinated with software and intelligent systems. I'm currently an L6 senior software engineer at Amazon, and I received my bachelor's, master's, and PhD in computer science. In these videos, I'll go over some new AI concepts as well as their implications for the future and hopefully how you can use their insights and leverage them in your own lives. Let's get started. Imagine you have two classrooms. In one classroom, you have students and a new teacher that's been hired fresh out of college. In the second classroom, you have students and a veteran teacher who has been teaching for years and years and years. Now, both classrooms are required to take a test, including the teachers. So everyone's taking the same test. However, in the classroom with the teacher who was hired fresh out of college, the teacher is able to look at their students' tests before they take and submit their own test. In the classroom with the veteran teacher must take the test at the same time as everyone else. So who does better? So in this example, all the students and all the teachers are AI models. In the classroom with the new hired teacher, all the students and the teacher themselves are open source models. In the classroom with the veteran teacher themselves are GPT-4 Omni, the state-of-the-art at the time the paper was published. So even though it was open source models versus the current state-of-the-art, the open source models were able to outperform the GPT-4 in a number of tests. Specifically, the authors ran 3 benchmarks, and the mixture of agents approach was able to outperform completely in 2 of the tests and in 5 of the 12 metrics in the 3rd test. So how does this work though? So you notice that in the example, there's 2 roles. There's students and then there's teachers. In the paper, what we're referring to as students are called proposers. They take an input and then they give some output that is proposed to some other entity that will take a look at them. And then the teachers are considered aggregators. They're looking at all the students' inputs, and then instead of picking the ones that they like, what they're doing is they're going through them and then they're having to synthesize and create their own solution to the test. So they're not picking the student that had the best response and then just copying and pasting. They're actually taking a look at all the inputs and then coming up with their own output. And the paper actually extends this even further. So this is just one round in which you have a row of students and then they take the test, they give their responses to the teacher takes a look at them all and then writes their own response to the test. In the paper, they actually go through a setup in which you could have multiple layers and do this iteratively. So you just keep doing this over and over again. So why does this work? The authors call this improvement the collaborativeness phenomenon, in which even though some of the responses from the students are not of high quality, just having a chance to take a look at them improves the performance of the teacher's response. So I imagine, if I had to guess, this collaborativeness phenomenon is probably comprised of at least 3 aspects. One, similar to the psychological impact of anchoring. The students are anchoring the aggregator in some manner. 2, there's some idea seeding going on from diverse perspectives. And number 3, just being able to go through this process multiple times, there's also a level of iterative, or rather repeated improvement. And I think all 3 of these, and probably some other stuff as well, are combining to improve the overall performance of the system. So what are some pros and cons to the approach? Well, at least two benefits. First one being you can get better performance, and the second one being you can do it cheaper as well. So in the first classroom, it's all open source models. Those are faster and easier to run or cheaper to run rather, than than the state of the art, or at least it can be, depending on pricing. The downside of the approach is though there's more complexity in the system. There's now multiple agents interacting with each other, and also latency. So since it's going through multiple rounds, or even if it's only one round, it can be slower than a single shot through a single model. So it's a little bit slower, but potentially better performance and save yourself some money. So what are some implications for the future? I think what we're starting to see, or what we've been seeing this year, is a rise of collaboration-based techniques, in addition to a lot of cool techniques for individual models. So mixture of experts isn't a new thing. For instance, Mistral released their model in which they use a similar concept, but inside a single model. This paper is basically taking that to the next level, in which you have multiple models themselves as the experts, right? So actually, in terms of what I mentioned on more collaboration and multi-agent systems moving forward, I think there was a paper from Vanguard as well that came out recently, and they essentially built an entire research team using agents as well, using similar mixture of agents approaches. So we're just going to see more and more of ensemble approaches in which there's multiple models working together. I think another takeaway is that moving forward, if you want to develop a well-rounded understanding of modern AI techniques, it won't be enough to know just about model architecture. So number of parameters, number of layers, types of layers, activation functions, multi-head attention, etc. But in addition to all that, you'll probably also need to know a bit more about system design. So multi-agent systems, how they communicate and how they collaborate as well. If you're not in the AI space, I think there's still a good takeaway that we can all get, and that's basically to seek diverse perspectives, even if you disagree. Because as the adage goes, you can learn something from everyone. All right, that's all for this video. Thanks for watching. Thanks to the authors for an awesome paper, and like and subscribe if you want to help me keep cooking. Cheers, see you later.